In this video, I'm going to take you through the process of analysis and design of a three-story residential building using the software ProtaStructure. At this stage, we have already completed the structural framing and modeling, and now it's time to put the building to test. We will be running the structural analysis to determine the actual forces acting on every beams, slabs, and columns, and then proceed to design each members to safely carry those forces while keeping the structure economical. You will see how ProtaStructure automatically applies load combinations, check for deflections and stability, and ensures our design meets code requirements. And remember, this entire project sits on a beam raft foundation, which we will also finalize later in this series. By the end of this video, you will understand how to turn a model output into a safe, code compliant, and cost-effective design ready for detailing and construction. I'm Miracle Okeke Richard. Welcome to SamGoz Engineering. And in this channel, I help you develop the required skills and enhance your knowledge to elevate your engineering career. So if this is what you want, you can quickly subscribe. This video will all be about analysis and design. We have done the general arrangement drawing, that's structural framing of this three-story residential building, and from there we're able to expose the governing principle in both column placement, beam placement, and also slab placement. And in our last video, we did the modeling of this video. We were able to come to this. We added this parapet road and many things that we did in the modeling. So right now, this video is all about analysis and design. So we are going to analyze this building and also design this building. So coming over to analysis, we'll come to this analysis tab. We'll click on analysis, then we'll click on building analysis. Here we are going to click on building analysis. So a dialog box will appear. Let's wait for it. So this is the dialog box that appears. If you can remember, we said that once our building is more than 10 meters, once the height is more than 10 meters, we are going to apply wind load. So let's apply our wind load. So I'll click on wind and story load. I'll come to this place that says wind load calculator. So I'll click on it, wind load calculator. So let's allow it to open. So at this point, look at what they're asking me. They're asking for basic wind speed. So basic wind speed in my area where I'm designing this building, the wind speed there is 30 meters per second. Yes, but if you want to get the wind speed of your area, you'll browse about the wind speed of that location in the last 5 years. Yes, once you get the wind speed of that location in the last 5 years, then you now take the average. Yes, don't browse, don't go beyond, don't go and be doing in the last 20 years or in the last 30 years, because you know that once it comes to last 30 years, maybe that time the number of buildings that in that area is few. That means the wind speed then will be very high. But maybe recently they have started the development has started entering that area. So that means there are more buildings now. That means those buildings will be restricting wind, like it will be restricting the wind speed. So that's why you should just take between from now to last 5 years. So coming over to minimum wind pressure, this is the minimum wind speed. So you just leave this one as default. Since you don't know the minimum wind speed in that your area, you can never dictate it, or just leave it as 0.5, because this is just the minimum. So this one is the primary wind angle. So I also advise that you leave it at 0, because you don't know the angle the wind is coming from. You don't know whether it's from 90 degrees, 30 degrees, or 40 degrees. You don't know the angle. So since you don't know the angle of your wind, but if you know the angle, you can put to. But me, I'll advise leave this as default. So coming over to this place, like from this high hill and also to this LO bracket, I'll advise you to leave it at default, because look at it, everything here is all about here. So if you see, S stands for the distance of the hill to look at it. S is the horizontal distance of the site from the top of the crest. That's this hill now. The distance from this point, that's the top of this crest, to where your building is located. But if you can get it, you can input it. But if you don't know it, you can just leave it as default. Even D is just, look at the actual length of the downward slope in the wind direction. That's from this downward slope from to your to where your building is located. But if you don't also know it, you can leave it as default. That's why I'll advise leave this area as default. Then total building height has been calculated by the software, which is 12 meters, is above 10 meters. So that's why we are adding wind, that's why we are adding the wind speed. So this one is hill type. So I will advise you to leave it as this script. Leave it like this. Then upward or downward wind, leave it as upward wind. Leave it as upwind. Reason why is because if you take downwind, that means downwind will be giving more stability to that structure. Yes, because once a wind is being applied on a building downward, that means it's it's sending it down to the soil. Yeah, and once it's pulling it down to the soil, that means it's giving that building more stability. But upward wind, it will try to pull it away from the soil, will try to raise it up. That means the stability of the building is at risk. So I'll advise you to leave it as well, upward wind. Then these ones, you can leave these ones at default. Then at this point, terrain category, you can just come and choose your terrain category. It depends. This one for sea coastal, if your building is located near the sea. But remember, if you choose this, that means the software automatically increase the wind coming to your structure. Yeah, because if your building is located near the sea, that means there will be high wind pressure in that area. So you just choose the one that best describe where your building will be located. So in my own is this category 4, which is area in which at least 15% of the surface is covered by building and the average height exceeds 15 meters. So this best category that describe where my building is located. So I'll click on it and then come over to this one and click on OK. So right now we have applied our wind road. So at this point, look at building category. It depends. If you are designing for steel, you can choose this. If it's composite, composite, it means that's where concrete and steel combined together. So anyone you are doing, but in this case, this is a three-story residential building and is a reinforced concrete structure. So at this point, I'll just come and click on apply. So I've applied my wind road. I'll click on OK. So at this point, next thing is to come and choose my material. So I'll come over to my material, then I'll click on this, which is this, to choose my concrete grade. So I'll come the concrete grade I would like to use is what, grade 20. This is grade 25. Now that's compressive strength. So I'll prefer to use grade 20, which is this. I'll click on apply to all members and then click on OK. Then come, if you see everything has changed, then come over to my steel grade. The steel grade I would like to use is this grade 460 type 2. Yes, I'll click on grade 460 type 2. Then in case, look at this rebar symbol. If you don't want it to be in T, for example, if you want Y, you can input Y here. If you want, so it depends on the one you want, but me, I prefer T, so I'll leave it at what, T. So look at 460 type 2. So I'll come and click on apply to all members. Then look at rebar diameter. You come and click on edit to choose your rebar diameter. So coming over to column, I would like my column to be this Y16. Yes, then I would not like to check any other one again. If 4Y16 fails, it should give me 6Y16. I don't want Y20. Yeah, because I know my client will not like Y20. So there's no need of me applying Y20 because I know that this Y16, if it fails, it will just increase the number maybe to 4, 6 or so. Then coming to shear wall, I don't have any shear wall, so I leave it. Then coming to beam, I will still repeat the same only Y16. If it fails, it should increase the number. Like if 2Y16 fails, it should take it to 4 or 3. Yes, that's what I prefer. Then coming over to slab, I also prefer Y12 in slab, only Y12. Yes, I don't want any other slab. Then coming over to lip slab, I don't have any lip slab in this. This is not, I designed with a solid slab, not lip slab, so I'll leave this as a blank. I'll leave it blank. Then coming over to foundation, remember this is a beam lab foundation, so we are using Y16. Yes, me, I don't want Y20. I don't want this, and don't also want this. So we are leaving it as well Y16. Yeah, because this is we are working with beam raft foundation. Then coming over to my ring, I would like it to be 10, so I will deselect the rest. Then coming over to this one is for shear wall. That's the shear wall. So since I don't have any shear wall in this building, I'll just leave it as default and then click on OK. So if you see now, I've clicked on this, I'll then come over and click on OK. If you see everything has been adjusted, then I'll come over to my foundation. So coming over to my foundation, the foundation type, I'll click on my concrete grade, which is still, I would like to use this compressive strength of 420. I'll click on apply to all members and then click on OK. Then coming over to my steel grade, I would like to use 460. Yes, I'll leave this. If you check your this thing, that means the previous settings we did is still intact. Look at it, Y16. So I'll just come and click on OK, then click on apply to all members and then come over to this point and also click on OK. Yeah, okay, this one I'll come and also select 460. That's for my ring. I'll select 460, click on apply to all member and click on OK. Yeah, this one is for my rings. Then coming over to the soil type, and you know the bearing capacity of our soil is 75. Yes, the bearing capacity of our soil is 75. That's why we're going for a beam raft foundation. And the soil type we're having there is silt, not sand. So it's silt. I'll come over to this point and then click on OK. So once I'm through with all this, I'll also come over to this point and click on OK. Then once I'm through with all this, the next thing I'll do now is to go to analysis and design. In our previous videos, we did the building model check. So right now we're going into analysis and design. So I'll click on it. Let's allow it to open. So this is where we are now. Some people will like to do the building analysis first, then then after they will now do the design. But in this video, I would like to do both the building analysis and the design at once. It all depends on you. So in this select bar, I will advise you, if it is your first time of carrying out the design of that project, if it's your first time, check this select bar. But if it's that you have done your interactive design, you have designed it before and you have done your interactive design, please don't click on the select bar, because if you click on the select bar, everything you have done in your interactive design will just scatter. They will scatter it for you. They will reselect all of them for you. So if you have not done your interactive design, click on the select bar. But if you have done your interactive design, please don't click on the select bar. So at this point, what I'll do is I'll click on building analysis. So we'll allow it to analyze our building. So look at it, it's analyzing our building now, and after this, it will design our building. So while we are waiting for this to design and to analyze and design our building, remember we went from the structural framing to modeling, and now we are currently at analysis and design phase. And the link to all those videos is in this video description. Don't forget, you can get the CAD file. Yes, the CAD file of this is available. You can get it and also practice on your own, because practice makes perfect. The more you practice this, the more you are able to learn. Now they are doing our column reinforcement design. So the more you practice this, the more you get to know, or the more you get to know it. If you watch 100 videos and another person just watch only 10 videos and practice those 10 videos that he watched, that I bet you and I promise you that person will be far better than you. So practice makes perfect. Make sure you practice, don't just watch. So now is in beam design. So let's allow it to design our beam for us. So as we are waiting for it. Make sure you practice. Make sure you like this video. Yeah, if you are also finding this video helpful, please do also swear to like the video. Don't just like the video, you can as well share the video in your class group if you're a student, or in your work group if you're practicing engineer. So you can do well to share the video so that more people will get to see, and also more people will get to learn alongside you. Yes, don't learn alone. Let other people learn with you together. So now it's still designing. It's currently in story 2. Look at it, story 2. Now they have entered story 3. So we are in story 3. Very soon now the building design will be over. So we are currently at story 4. Yeah, it's designing the story 4 beams. So if you look at it, it's moving. So we are almost through with the design. Yes, we are through with the design. So this is it. If your relative story drift fails, what it means is that you have to increase the size of your column, or you increase the number of your column. That's if you are seeing bad here. That's if it fails in direction 1 and in direction 2. What it means is that you go and increase the number of your column, or you increase the size of your column, one of them. So after seeing this, the next thing to do is I'll come and click on OK. If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group, so that more people will get to see this and they will also learn alongside you. So I'm through with my design. If you come over to this building analysis, look at it. It has been checked, it has been marked blue. That means I've designed this building. So I'll come over to display. Once I come over to display, this is visual interrogation. I'll click on it, then I'll come over to design status, then click on my design status, then click on OK. So with this now, I'll see the ones that are failing and the ones that are passing. So if you can see, I have some of my columns failing. Some of my columns, they are failing. Yeah, this column is also failing. This column in story 2 is also failing. Then almost all my beams they passed, right? So almost all of them they pass. But even though that your beams they are passing, even if your columns and your beams, if they are passing, please make sure you do your interactive design. Make sure it is a compulsory something, not if it passes you leave it. So to do my interactive design, I'll come over to my plan view, then I'll turn on my visual interrogation for plan view too. I'll click on this, then come over to visual interrogate design status and click on this. Yes, okay, I forgot to say something. Look at it. Green means that it has been designed, while white means it has not yet been designed. For example, look at our slabs. They are white in color, meaning that we have not yet designed them. Yes, orange is just expired analysis. Why lead means failure. Look at this one's on lead, they mean failure. So I'll come over to my plan view, I'll come over to my story one and start doing my interactive design one after the other. So but I'll not do interactive design for everything. I'll do something like 5 of the beans, then I'll come over to column and do for column 2. Then on your own, if you get the CAD file, you can now do the interactive design of all of them once you get the CAD file. Remember, the link to the CAD file is in this video description. You can get it there. So I'll click on this beam. Once I click on, I'll right click, then click on section design. Then I'll click on section design. So this is what I'm having right now. Yes, they're giving me 3y16 and 2y16, 2y16. So this is okay for me, but I would like to rearrange this beam. I would not like to have it like this, even though I'm still having 3y16 here. So I will escape, come over to this one, click on this. Look at, I'll come over to extend light. I'll come extend right to lap. I'll click on this and also come over to this part and click on, I'll click on this, then click on extend left to lap. I'll click on this. So once it has lap, I'll come over to this point and increase it to I'll increase it by one number. So what I'm having here total is what, 3y16. Yes, because this is 2y16, so 2y16 is passing here, then plus this one is still 3y16, so it is still the same thing. But if you arrange it like this, your detailed drawing will be arranged well. Yeah, if you leave it like this, your detailed drawing, the arrangement will be more accurate. So I'll just explain to you the difference in ProtaStructure and how to solve them. Yeah, we have about 5 force failing in ProtaStructure. First, your beam can fail in bending. Yeah, bending means that you have not yet provided enough reinforcement to counter the bending moment. For example, assuming I'm having one reinforcement here. So okay, assuming I'm having one, okay, let me just, for example, assuming I'm having, so let me increase this one back to 2. Yes, assuming I'm having one reinforcement here. Look at, it is failing here, meaning that it is failing in bending, like in moments, not bending, it's failing in moments. Yeah, that means I need to provide more reinforcement to counter the moment acting on this beam, because you know this, the bending moment diagram is like this, then it will go up, come down again, then terminate at 0. So to provide more moment, to provide more reinforcement to counter it, you increase it. Yeah, you keep on increasing it, it passes. Let's go over to the bending moment diagram. So this is the bending moment diagram. So let's click on it. So let's wait for it to appear. So look at it. If you see, there is a hugging moment here. This is sagging moment. This is the reason why I say you should always hinge your beam members. Look at it. It's starting from 0. But if I do not hinge this beam member now, it is here will not start from 0. Like I'll be having moment here, and ProtaStructure will design to counter that moment. That's as me, I do not hinge my beam member being modeling. Yeah, I'll be having this moment diagram now will look like this. It will come like this, then it will not go up, come down. That means there will be a moment here, and ProtaStructure will provide reinforcement to counter that moment. That's why I'm having 3y16 here, because of this moment here. So ProtaStructure provided bars, it provided reinforcement to counter this moment. Yes, it's correct. So that's why you must hinge your beam members to avoid over design. Yeah, not to waste your client's money, because first is safety. Once it comes to design, first safety, after safety it comes to economy. So you have to be economical in your design, so you not be so you not really waste your client's money anyhow. So come over to this point. So because of this high moment, that's why we are having 3y16. So you keep on increasing this reinforcement till it passes. Then it can fail in shear. That's right. This, look at it. It can fail in shear. Fail means what I call sudden failure, or sudden, just like sliding. Yeah, that's shear, just like sliding. So it can also fail in shear. So if it fail in shear, that means it will be failing here. You'll be seeing this thing in, like here. Let me say, okay, it's just I cannot increase this again. But if it fails in fear, if it fails in shear, you come and decrease the spacing of your reinforcement. Yes, you come and decrease the spacing of your reinforcement. But if you keep on decreasing the spacing and it keeps on failing, you now come over to this point, to this beam, and then increase your beam depth. Yes, and increase your beam depth. So I'll come over to my rebar because it's not failing in shear. So okay, another failure that I can have is, for example, look at another failure. Look at this, another failure. For example, yes, if here is red in color, this is another failure. So if here is red in color, what you will do is that make sure it is not less than 20 millimeter. Yes, because the size of our coarse aggregate is 3/4. Yes, 3/4. That means if that's our gravel, our coarse aggregate is our gravel. If the size is 3/4 and that 3/4 is 20 millimeter, so make sure, because this is the spacing between your rebars. Okay, let's come over to detailed drawing. So I'll explain this in very well, so you understand. So let's wait for it to appear. Detailed drawing. Let's wait for it to appear. So look at it. So assuming that spacing, what it means, that lead bar, for example, that one I'm seeing 18. What it means that difference between here to here. Okay, wait. Let me increase this so you understand it. Wait, let me just increase this. Let me just take it to 5. Yes, let me take it to 5. If you see, it's failing here. It's 18. So let me now explain it so you understand it. So let's wait for it to appear. So look at it. Look at what it means. What it means that the spacing between here and here is 18 millimeters. Yes, the spacing between this bar and this bar is 18 millimeters. So what do you ensure that is not less than 20 millimeters, because our coarse aggregate is 20 millimeters. That's 3/4. That's our gravel is 20 millimeters. So if it is less than 20 millimeters, that means your coarse aggregate will not be able to pass through this reinforcement. Yeah, so that's why I say ensure that it's less than it is not less than 20 meters. But if it is above 20 millimeters, even though it's showing red, you can leave it because your coarse aggregate will be able to pass through. So I'll come over and exist this. So I think I've explained all the whole failures. Okay, yeah, there is also another failure. Another failure is the diffraction failure. Yes, diffraction failure. Where is diffraction? Look at it, diffraction shake. So assuming is failing here, this is diffraction shake. Assuming is failing, let me also decrease this. So assuming it's failing in this deflection, what you do once it is failing in deflection, what you do is that you increase your beam depth. You come over to this point and increase your beam depth. That's if it is failing in deflection. In deflection is a must that you must increase the beam depth. Okay, what does it mean for a beam member to fail in deflection? A beam member failing in deflection doesn't necessarily mean that structure will collapse. No, it won't collapse because you have provided reinforcement to counter the moment. Is when you do not provide enough reinforcement to counter the moment, that is when your beam member will collapse. But if it fails in deflection, what it means is that the beam will be able to carry the load, but while carrying that load, it will deflate. Yes, and to remember, if it deflates, it will no longer be aesthetically pleasing because once it deflates, it will now cause cracks on your block wall. And once your block wall start cracking, that means when I say they will take you like one nonsense engineer did the job. Yeah, so make sure your beam do not fail in deflection. Once it fails in deflection, please increase your beam depth because it will cause the beam to deflate while carrying the load, and that deflection will cause cracks on your block wall, but the beam will not fail, but it will cause crack on your block wall. That means your structure will no longer be that beautiful again. Yeah, because people will be seeing cracks on the block wall. So with this, I think I'm through with this. I've explained every failure in beam. Yeah, so I'll come and click on OK. So that's why, remember, if you are finding this video helpful, you can equally subscribe to this channel. Not just subscribe, you can share this video. Yes, if you're a student, you can share it to your classmates so that they also watch and learn. Don't learn alone. If you're working engineer, that's a practicing engineer, you can share it in your work group. Don't just learn alone. So with this now, let's come and shake this beam. Yeah, but in this beam now, I will be fast because I'll explain everything I need to explain. So look at it, 2x16, 2x16. So everything is okay since I'm having 2x16. Let me also come over and shake this beam. I'll right click, then click on section design. Look at it, okay, 3y16. Remember, I told you during our chrome placement that we might be having 3y16 here. So it's okay. Yes, okay. There's also another thing I forgot to mention. Make sure that this is the area of steel provided. So this is the area of steel required. Why this is the area of steel provided? So make sure that the area of steel provided is not less than 100 millimeters. Reason is because I'm located in an African country. Yes, and in this African country, they tamper with quality. Yeah. All this company, all this production company, they are trying to make profit from their product. Yeah, so our Y16, that's our reinforcement Y16, it is no longer Y16. If you go to the market now, that Y16 will be something like, because me, I'm based in Nigeria, and if I go to market, my Y16 will be something like Y14, Y15, or even Y13. None of them will be up to Y16. And also we use the yield strength of 460. So if I also go to market, I'm sure that those reinforcement, their yield strength is not up to even 437. So to counter those losses, that's why we ensure that our area of steel provided is at least 100 millimeter. It is not below 100 millimeter. If it is below 100 millimeter, please increase your reinforcement to prevent building collapse. Yeah, to prevent it will be a shame that you finish designing your structure and that building collapse because of you ignore all these small errors. Yeah, so make sure here is above 100. But if you're in all these European countries, South Africa, where they don't tamper with quality, even if you're getting 50, leave it like that. Even if you're getting 30, leave it like that. Yes, because your country, they don't tamper with quality. But if you're in all this African country where quality is being tampered with, please make sure it is above 100. So look at what this thing means. This is the area of steel required, and then look at this thing means that we provided excess, that we provided 2830 excess area of steel, because this is the amount required. Then we provided excess. But the thing is that if you decrease this now, if you decrease this to 2, it will start failing. That means it is failing because I've not yet provided enough area of steel. Like I still have to provide up to 4 to match this. So if I now increase it, that means I'm not providing excess, which is okay. I hope you are understanding and you are gaining a lot from this video. So I'll just shake one more beam, and then move over to Chrome to prevent so that this video will not be that lengthy. So I'll come and check, okay, let me check this column, let me check this beam. I'll then click on section design. So this is what I'm having, 2y16. So this is less than 100. It is less than 100. Please increase it to prevent building collapse. So I'll come and click on okay. So right now we'll be going over to our column. So I'll escape. So coming over to our column, I'll click on it again, then likely click on section design. Yes, section design. Let's wait for dialog box to appear. So this is what we're having. So if you see, okay, let's click on interactive design. So if you can see, it is failing. Look at it, still ratio limit exceeded. So what we'll do in this case, remember in our structural framing, I told you that most of our column will be failing. Yes, if you have not watched that structural framing, please go and watch it, because I really explained a lot in that structural framing. I explained the governing principles in column placement, beam placement, and also slab placement. I also told you that limit the point load acting on your beam to avoid excessive moment on that beam. Yes, I explained a lot. So if you have not watched the video on structural framing, please go and watch it. So right now, this is what we're having now. So what it means that I have to increase the reinforcement, I have to increase the dimension of this column. So I'll write to go by 300. I'll click on update. So this is what I'm having. I'll then come over to interactive design. So I'm having 4y16. But there is a but. Let me just show you something. Look at it here. It's failing in slenderness. Yes, this column now is failing in slenderness. Let me explain what slenderness. What if a column fails in slenderness? It doesn't really mean that that column will not really carry that load. No, that's not what it means. But it means that it will really bend a little bit while carrying the load. Yes, but I could have increased it. Okay, let me click on okay. Let me just increase. Let me make here 300, and then make here. Let me make it. Let me make here. Let me say 800. Okay, let me say 500. You know, for example, this column should fail. So let me click on update, reselect bar, and then click on interactive design. And so if you see, even upon that 300 by 500, this column is still failing in slenderness. So slenderness is just a ratio of square. Like it means that your building should be more of a square for that column not to fail in slenderness. And also remember, okay, let me explain something. Column fails in two methods. We have two types of column. We have a short column and a long column. A short column fails by crushing, that's squashing. It's just like as if you just crush something or squash something, while a long column fails by buckling. And two, it is from that buckling, that long column, that will got slenderness ratio. So this column now failing in slenderness means that you should increase the size of that column. But remember, I'm trying for this thing to align with the block wall. Yeah, I'm trying to I want my column to suit with my block wall. So even though this thing is failing in slenderness, it doesn't mean that your column, it doesn't mean that your structure will fail. It's just that your column will buckle a little bit while carrying the load, but it doesn't mean that it will fail. Yeah, so since, okay, let me click on okay. Since I'm having even 300 by 500 is failing, that means I cannot really do anything about it. It's only when something like I have something like, let me say 500 here, that it will start passing, because it will be more of a square. Yes, let me click on the select and then click on interactive design. It will not be more of a square. Look at it, it's not passing. But I would like to use at least a size of 225, a size of minimum 250. I will just come and click on okay. So I would like here to be 300. I don't know whether you understand what I'm saying. Then why here? Let me choose let me just choose 250 and then click on update. Then click on the select bar and then click on OK. So if you can see, it is still failing in slenderness. Yes, it is still failing in slenderness. So I just want you to understand something. So what I'll just do is that I'll still leave it in 225 by 225. My building will not collapse. Yes, it won't collapse, but it's just like the column might just tilt a bit. Because okay, let me just click on update and then click on the select bar, click on interactive design. So if you see, it is 1.2 greater than 1. So it's just 0.2. It doesn't mean that it will, the buckling or the bending will not be that visible to sight. Yes, is as me I'm having something like 4 greater than 1, 5 greater than 1. That means that buckling will be visible to the eyes. But in this case, it is very small, which is 1.2 greater than 1. That buckling will not be visible to the eyes, but it will buckle a little bit. It doesn't mean that the column will fail. No, the building will not collapse. It's just that it will carry the load coming to it while buckling, because this is a long column. Because I told you once it comes to long column, that's when you have slenderness ratio. So it will buckle while carrying the load, but the buckling is very minimal. So that's why I'll agree to use 225 by 300 size of column. I don't know whether you understood what I explained. Yes, so these are the engineering principle behind the design that we'll do. We don't just assume values. Yeah, so I'll just come and click on Okay. Yes. Okay. They're asking me the following analysis result will be invalid if you proceed. That's the building analysis result will be invalid. I'll click on no. It should not be invalid. So what I'll do now is that I'll right click. I'll right click now. I'll right click. Then click on update still bar. Update still bar. So look at it. It has been updated. Yes. So I'll do few more columns. Then continue. Do few more columns. Then I will now end it. You can now get the cat file and practice on your own and do all of them, because the more you do this thing, the more you get to learn. Let me tell you, even if you watch 100 videos and practice none, and another person just watch only 10 and practice those 10, I bet you that person that practiced 10 will be far better than the person that watched 100 without practicing any. So you can get the cat file of this video using the link in this video description. You can get it. It's very cheap. Yeah, you can get it and practice on your own, because practice makes perfect. Remember, consistency beats intensity, and also be consistent in your practice. So yeah, okay, wait, I want to check something. I forgot to share something. Okay, this is the column I'm going for. So I'll click again, click on section design. Then I'll come over to this point and increase it to 300. So 300. I'll click on update. So this one I'm having. I'll click on reselect bar and then click on interactive design. So I'm having this 4x16. I'll click on OK. So come. I'll say no again. Once I say no, I'll then click on update still bar. So this is what I'm having. So I'll come over. Okay, look at this one is failing. This column is failing again. I'll click on session design. Remember, I will not do all of them. Maybe after this, I'll do 2 more and then stop. Then what I'll do is that I'll come here, increase this one to 300. Click on update. If you see that now I'm increasing this one to 300, this side 300, I'll show you the reason why I increase it to 300. Click on select bar, click on interactive design. So I'm having this. Okay, I'm having 8y16. So I'll click on OK. 8y16. So I'm okay with this. So I'll click on OK. So I'll still click on no. Yes, I'll still click on no. I'll escape. Then I click on update still bar. So look at it, it's has been updated. But if you see, I'm having small offset outward. So doing my detailing, I'll move this column inwards. Yeah, I'll move it inside so it will align with the wall, or it will flush with the wall. So if you are also this one, I'll be getting the same thing. I'll be getting the same thing. Yes, I'll be getting the same thing. I'll still be getting that 8y16. Look at it. I'll do it 300. Update interactive design. Then I'm having it. Look at it to be 8y16. It will be 20. Yes, I'll click on OK, then click on no, then I'll escape, right click, then click on update still bar. Reason why I'm still having 8y16, you know, this side and this side, they are the same thing. So it is the same load that this column is carrying, that this load is also carrying, that this column is also carrying. Remember, once it comes to detailing, I want to tell you whether this column should be positioned like this, or it should be like this. Yeah, once it comes to detailing. So make sure you watch our detailing video, because I'll be explaining it. Yes, you know, here I just made it to go, I made it to be like this, any of them. Yeah, but in detailing, I'll tell you whether should it be like this, or I should be having it like this. Yeah, once it comes to detailing, that's when I'll explain this. So let me do one more column. Okay, let me do one of the perimeter columns. So I'll click on update still over ascension design. Let's wait for it. So this is what I'm having: 2y16, 4y16. So it's okay. I don't need to check more again. So if you see, let me tell you something. All our perimeter columns, they will be 2y16, but they will be 4y16. Yes. Do you know why they are 4y16? Because they are carrying a lesser load. Okay. Let me go over to display. Let me go over to let me come over to this post and show you something. Look at it. I'm having I'll click on building analysis model, building analytical model. Let's wait for it to appear. So it's ready. Remember, you can get the cat file. Remember, if you are finding this video helpful, please share. You can share to your friends, your classmates, and everybody, so people will get to learn, not just only you. So this is what I'm having right now. So I'll come to solid model. Let me explain something to you. Why those, okay, if you see like this, okay, the ones on blue means that the force coming to them is very high. Then blue means that it is carrying a force of 440. Yeah. Why these ones on lead? Yeah, they are carrying 4.432. That means the force coming to them is very, very low. And two, these ones on lead, they are mostly the ones on top, because what they are carrying is roof load. Remember, in column, the load is being transferred downward, in the sense that this beam and this beam will transfer east load to this column. Then this column will not transfer east load to this column, and then this beam and this beam will also transfer east load to this column. Then this column now will not transfer east load to this yellow column. Then this one and this one will not transfer, this beam and this beam will also transfer east load to east column. Then this column now, this column on top will transfer it to this one. Then this and this will also transfer east load to this. Then this column will not transfer it to the foundation. Why foundation will not transfer why the foundation will not transfer it to the soil, then the soil will not carry the load. So that's why these ones, they are the ones on this red color. Why, if the column is moving downwards, if the column is moving downward, you see it will be moving up. That's here. Okay, let's use this one for example. Look at it. The top is this color, followed by orange, then followed by yellow. Look at it, then followed by green. The green here. So what I want to explain is that all my perimeter column, they are carrying a lesser load. Yes, they are carrying a lesser load. If you check, all of them are from green downward. Why all this column inside, all my column that are inside, they are carrying a very heavy load. That's why you are seeing them blue, and few. In fact, all of them are blue. Look at it, all my inner columns, all of them are blue. So that's why my inner columns are failing. So what I will do in detailing is that once I come over to inner column, I will do them 225 by 300. That's what I will do. Once I come to my inner column, I'll do them 225 by 300. While for my outer columns, I'll do them 225 by 225 because they are kind of lesser load. Yes, I hope I've been explaining. Look at it. Inner column, blue. All of them are carrying a very less load. Like, look at this one. Okay, it's just this one that is carrying a load that is somehow high. Look at it here. It's carrying 292. Yeah, it's a load that is somehow high, but we'll still check it to know whether they are giving us 225 by 225. But if they are not giving us 225 by 225, that means all my inner columns will be 225 by 300 and my outer columns will be 225 by 225. Yes, because they are carrying a lesser load. I hope you understood this and I just explained that. These inner columns, they are carrying a very heavy load. That's why they are failing, and that's why it is 225 by 300. So I'll come over to this point. I'll come over and click on my plan view again. So let's enter.
If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside you.
So I'll still check few of my outer columns. Yes, few of my perimeter column. I'll like click on section design. Yes, I'm having it to be, let's wait for it. I'm having it to be this. Is okay. It's okay. I don't need to check more. Let me check this one. I know we're having that this one was a little bit. We are having that this one was, let's say, blue in color. So let's check what the software is giving us on this. So look at it, it's stay 4y16. So I'm perfectly okay with this. And also let me also check this one. Right click session design. I mean say session design. So let's wait for it. So I'm okay with this. Yes, I'm okay with this. But let me check one of these perimeter columns. Let's check. Let me see what is it. Okay, let me check. Let me see what this one is giving us. So I'll click on section design. So I'll click on section design. Let me see. Let's see. Okay, if you see, you can, it's even frame. That's why I said that all my inner columns will be 225 by what 300. So I'll come and make here 300. So I'll make it 300 update. Yes, then there's a red bar, interactive design. Then this is what I'm having 4y16. So I'm okay with it. And then I'll click on OK. So I'll click on no. Then once I click on no, I'll like click on update steel bar. I'll look for it. Where's update steel bar? Update steel bar. Where is update steel bar? Okay, let me just escape. I'll escape. I click again. Update steel bar. So if you look at it, it has been updated. So that's why I say all my inner columns will be 225 by 300. Let me also check this one. Section design. This video is already taking long, but I believe that you're really learning something. So I will still change it by 300. Update, then interactive design. So then you can get the CAD file on your own. You do the whole column. That's why I say don't just take whatever the software is giving you. Please don't just take it. Make sure you carry out your interactive design. It is very necessary. So this is what I'm having right now. Yes, remember I told you in detailing will be determined should this column be like this or should it be in this direction or should it be in this direction. That's when in detailing I will explain it to you. So make sure you watch the detailing of this video. So right now I think I've come to the conclusion of this. All my inner columns will be 225 by 300, and then coming over to this one now. This one now will be this one will be 225 by 300, but it will be 8 numbers of reinforcement, while the rest will be 225 by 300, but 4 numbers of reinforcement. Okay, remember, this building here and here is typical. So let me just check one. Let me just check this one. So I will be sure that I've checked everything. So I'll click on section design. I'll click on section design. Okay, it's giving me 4y16, but I'll still use 225 by what 300. It's giving me 4y16, but I'll still use it as 225 by 300. Yes, I'll click on okay. I'll still use 225 by 300. So I'll escape. Remember, some of our columns were failing in story 2. So I'll come over to story 2. So look at it. This one is failing. So I'm sure if I will just click on it and I will still be having 225 by 300 at that thing that I said. I said that all of them must be 225 by what 300. So I'll just say 300. I'll click on update. interactive design. Then this is what I'm having, 4Y16, so I'm okay with it. And then I'll click on OK. So I'll click on no. Alright, click on update steel bar. So this is what I'm having. So right now, what I know is that all my inner columns will be 225 by what? 225. Sorry, all my inner columns will be 225 by 300. Why all my outer columns will be 225 by 300, 225 by 225. Why this column now will be 225 by 300, but 8 numbers of reinforcement. So because of the length of this video, I will not be doing all of them. So what I'll be doing next is just the slab design. Yeah, the slab design. So I'll come over to story 1. I would like to do the slab design on story 1. So on your own, if you get the CAD file, you can just finish up everything. I've made the conclusion. I've drawn conclusion from my result. So I'll come over to slab design, but on my own, I'll really check all my whole columns. I'll check the whole columns. That's if I'm doing it on my own, but because of the length of this video, I'll not be doing everything. So to do the slab design, I'll come over to modeling. I'll come over to modeling, come over to slab slips. Yeah, slab slips. So once I'm here, what I'll do is that, remember, boundary condition. So for example, this, okay, I'm doing for S axis first. So this is the boundary condition, this and this, because this is void, beam, and then slab. Look at it, void, beam, and then slab. And the ending back condition, look at it, beam, sorry, slab, beam, and void. Look at it, slab, beam, and then there's a void at the back. So these two are my boundary condition. So I'll click on this point, hold my control key, then click on this. So this is what I'm having. And also that boundary condition is still applicable to this point. Yes, it's still applicable to this point. Yes, so this is what I'm having. And that boundary condition is also still applicable to this point. Okay, wait, let me escape, sorry. So let me zoom very well so I'll get it. I'll hold my control key. Let's wait for it. I'll hold my control key. Yes, I've designed this slab. Then coming over to this point, and the boundary condition have changed. Look at, I'm having a slab, a beam, and then a slab. Then here, a slab, a beam, and a slab. So this will be my boundary condition. A slab, a beam, and a slab. A slab, a beam, and a slab. So these two will be my boundary condition. So I will select both of them. Then I'll click here, hold my control key to straighten the line, and then click on this. Yes, this video is taking long, so that's why I'm a little bit fast. Yes, to save time. Then I'll come over to my Y direction. So my boundary condition is this and this. Yes, a void, a beam, and a slab. So I'll come, look at it from this point. I'll hold my control key to straighten the line. I'll hold my control key. This is what I'll be having right now. Then then I'll come to this point. Then the boundary condition has changed. Remember, we have designed this beam already. So this will now be my boundary condition. A slab, a beam, and then a slab. So this will be my two boundary conditions. So I'll have this beam running like this. From this point, I'll hold my control key to this point. Yes, so this is what I'm having. Then the boundary condition have changed again. Look at, here is a void and here is a void. So these two will now be my boundary condition. So I'll move from this point to hold my control key. Okay, I'll hold my control key to this. So if you see, it has been designed. So let's check something. I'm having T12 at 250, T12 at 250, but doing detailing, I will not use T12 at 250. I'll be using T12 at 200. There is a reason for that, to prevent building collapse, because remember, this is I'm located in an African country, and to here they tamper with quality. If I go to the market now, this T12 is no longer T12. It will be something like T10 or T11. Yes, because the production company, they want to make gains. So that's why they will reduce the quality. And to remember, the yield strength that we use is what? 460. So the yield strength at market will be something like that kind, 410, 420. It will never be up to 460. So to counter all these losses, I will now decrease the spacing, so that, because once I decrease the spacing, what it means that I've increased the area of T provided. Do you understand? Once I decrease the spacing, moving from moving from T12 250, I will now do it T12 200. I've decreased the spacing, meaning that I've increased the area of tear. That means I'll be able to counter those losses. In fact, I'll just advise you generally, once you come to slab, make sure that your slab, the minimum spacing that you use in slab, that's my advice. Just use
200. That should be your minimum spacing once it comes to slab. So with this now, I believe that we have come to the end of this video. So this is what we have done. We have been able to, let's wait for the 3D view to appear. So look at this slab. I've been able to design this slab. Then on your own, you can get the CAD file. On your own, you design this slab, and also on your own, you carry out the interactive design of all the beams, of all the columns, and also design the slab on your own. Don't forget, you can share this video so that more people will get to learn. Don't just learn alone. And also, you can get the CAD file and practice on your own, because practice makes perfect. If you watch 100 videos without practicing any, and another person just watch only 10 and practice those 10 videos that you watch, I bet you that person will be far better than you. I know how I got good in structural design. That's why I'm saying all this. So invest in yourself now, so it won't be too late.